All right, have you all gotten a chance to sign the sign-in form? All right, sounds good. We're gonna get started now. This workshop's gonna be a bit different because we have a guest speaker from Deloitte coming. They're supposed to be coming at 5:30, but we might have to reschedule that depending on when they come. But yeah, first off, we're gonna go over behavioral interviews. Next, we're gonna go over technical interviews and then some other tips and resources as well. Uh, these interviews are really important to prepare for as a computer science student and anyone who's looking for a software engineering job. Um, but yeah, start off with the behavioral interview section. So what is a behavioral interview? Right. So we're splitting up the interviews into two sections, and this can be done before or after the technical interview, depending on the company. But most of the time, there is always a behavioral interview, and then maybe one or multiple technical interviews as well. So the behavioral interview is designed to evaluate your past experiences in professional situations to predict your future performance in the role. So they're testing for communication skills, things like teamwork and collaboration, problem solving abilities, and adaptability under pressure. Some common questions you might find are about into these four categories, right? So like, tell me about a time that you worked on a team project. Describe a time that you had a disagreement. In time management, how you prioritize tasks under tight deadlines. Leadership, what have you taken initiative? When have you taken initiative on a project? And for the most part, the questions are pretty generic, so you can kind of prepare these beforehand. But here and there, some companies will ask you some brain teasers or questions you can't really prepare for. For that, it's all up to you. It's all up to your soft skills. Soft skills, for those of you who don't know, is everything aside from your technical skills on your resume. So like how you communicate, how you function in the team setting. That's essentially what they're testing for. So the STAR method is the way you want to answer these questions. That stands for situation, task, action, and result. So starting off with what was the situation? So for example, it might be like, last semester, our project team faced a major roadblock due to a missing library, right? And then the task, what was your task in the situation? We needed to finish development under a tight deadline despite the missing tool, for example. Next is your action. What did you do? So you might be like, we researched alternative libraries, led the team in a decision-making meeting, and implemented the fix. And then the result of your actions, right? We delivered the project on time and it was well received by the client. So the thing we're looking for is in a situation where you might face an issue in your job that you're applying for, how are you able to think about that? How are you able to execute a solution to that? Right. So the way you want to prepare for this is just, like I said earlier, you're preparing specific stories for the common questions ahead of time. And for the most part, like these are repeated. So you can definitely prepare some things from your resume, some things that are not on your resume as well. And you also want to tailor your examples to the job description and company culture. So that means like if the job description is set for a specific language, a specific technology platform, you might want to tailor your stories to those rather than some other projects you might have, right? Study your resume. This is really important because if you had a workshop last week where we talked about what to include on your resume, we essentially said that your resume is a table of contents, right? It's a list of talking points for you to talk about in your interviews. Because obviously, if you're working somewhere for 3 months, let alone like 2 years, right, you're not going to be able to condense that into 3 bullet points. So that's essentially a table of contents, talking points that you're going to expand on throughout your interview as well. Because if you list something on your resume that you cannot explain, that's a really bad look for you. That just shows that you're dishonest, that you're not going to do your work on time or honestly, right? So you want to be able to talk about everything that you have listed on your resume. Take time to think about your answers. And a lot of recruiters will tell you this, but it's better to just say, hey, can I have a minute or two to think about this before I answer, rather than just rushing into an answer and giving an answer that didn't really relate to the question or something that doesn't answer the question fully. And aside from the questions that the recruiter asks you, you also have to prepare questions to ask the recruiter. It's a two-way interview, right? It's not just like a one-way interview from the recruiter to you. It's a discussion back and forth. Because this is your opportunity to learn about the company itself from someone who works there and someone who represents the company culture well. Now, keep in mind that your behavioral interview is going to be with a recruiter most likely, as opposed to like a technical manager or software engineer on the team. So your questions in the behavioral interview section should be more related to the company culture, to say role progression or how conflict gets handled. Stuff like that, that's not necessarily technical. Now, obviously, there's a chance that your behavioral interview is done with a technical person, in which case, that doesn't apply. But make sure to tailor your questions to who you're asking it to. And the last point I have on here is rehearse out loud with a friend. And, this isn't something that most people think to do. But preparing a question on a notepad document is very different from speaking it out loud. And you're gonna take time to study, you're gonna take time to think, because that's something you need to practice beforehand with a friend. I know, I think it's in data structure and algorithms that Aman actually has you prepare with a friend. And I think that's very valuable to do. But this can be just like a peer, a classmate. You can even do this with a connection you have with the company. Say, hey, can I have a 15-minute coffee chat? And then ask about some questions they might ask you in the interview, and then take the time to talk with them. And you're going to find a lot of value comes from that. And our behavioral interviews, there's not much else to go over besides what I talked about. So we're going to spend the majority of this time on the technical interviews. And you're going to present that. And keeping in mind, we have Deloitte coming at some point, so we might have to interrupt this section. Deloitte is here, okay. Yeah, so before we get to the technical interviews, we have.
Their colleague is coming, so go for it. And then
Okay, sure. Sounds good.
So, hey everyone, I'm Kai. I'll be talking about technical interviews today. So, just kind of a general overview of the higher level concepts and recommendations that are good practices for when you're doing a technical interview. We're not going to get too much into the low level, like how to actually code the problems, although we will be talking about some of the general types of problems. But really, you'll just need to practice those mostly on your own. But we'll refer you to good resources for that. So, first of all, what is a technical interview? Maybe you already know, but most of the time it will be some sort of coding challenge, very similar to a leak code problem, if you're familiar with that. So basically, you'll get some sort of problem statement, and then you'll be asked to, in that problem statement, to create usually some sort of function, maybe a class that will take in that input typically and produce some sort of output, by process the input and then output some other value. Typically, the interview will last around an hour, could be more, could be less, maybe, half an hour to an hour and a half, but that's a general reasonable estimate. And most of the time you'll be able to, especially for internships, they just mostly want to see that you can solve a problem. So you'll be able to select your own programming language, like whatever language you're most comfortable with, because they're not really looking most of the time for super specific, like language specific knowledge. I would recommend, especially if you're not already really invested and like really deep, you don't have like a deep knowledge of any programming language yet, I would say it's good to do interviews in Python. I think it's just a simple and concise language. You can write most things quickly and easily. There's a lot of built-in functions that are nice. But, a lot of people, if they already have, a lot of time invested and a lot of deep knowledge in like a language. So I know people who've had success with like C++, like Max, you do your interviews in C++, right? And that's gone well for him. So if you already know a language really well and you think it's not worth your time to switch to Python, that's a very viable option as well. So whatever you want to practice in and do your interviews in. But sometimes, so there are exceptions to that. Sometimes a company will want a specific language or technology. That's rare, especially for just internships. That's more typical for like a full-time role. What you'll need to know mainly for these types of problems, just data structure and algorithms, that will be the most relevant class or topic, because these problems are solved and solved efficiently by selecting the right data structure and using the right algorithm to solve it, as well as time complexity. So that's another big topic from the data structure and algorithms class, but it's used in other classes as well, because they're usually looking for ideally a more efficient solution to the problem. So being able to describe the time complexity and know and know and understand the time complexity of the solution you wrote. That's generally pretty important, as well as, of course, memory complexity. So that's going back to big O notation, if you remember that. And also often these problems are iterative, meaning that they'll give you kind of a simple problem, a simpler version of the problem, and then you'll build up a more complicated solution as you go. So once you solve the simple version of the problem, they might add some complication, and you'll need to edit your code to handle that. So I guess keep that in mind as you write your solution, that you might have to modify it, after you write it. So there are other types of technical interviews that are a little rare. So when I was talking about the more LeetCode style coding challenge problem, there are other alternatives. For example, sometimes it will involve much more object-oriented programming, where they'll ask you to design a class and demonstrate your knowledge of OOP, like, for example, inheritance and polymorphism, and just demonstrate that you know those concepts. And rarely, especially for internships, they might ask you a system design problem, which is kind of just designing a much more complicated application, like an app or a website. But especially for internships, that's not super common because it's a lot more like deeper knowledge that they don't necessarily require. But we're not going to be talking about these types of interviews today. We're talking more about the coding challenges. So I just recently found out about this mnemonic actually, but I really like it for how to approach a technical interview, which is the triple E method. So it's 3 E's, of course. So the first one, and it's in chronological order and kind of the stages you should move through as you're doing your interview. So the first is to explain, right? Once you receive, they'll tell you the problem statement, you don't want to just start coding a solution immediately, even if you think you have a good solution. Even if you think you understand the problem and you think you have a good solution, you don't want to start coding it immediately because you might be missing something about the problem statement. So you want to ask clarifying questions, right? Ask them, any questions you have, any uncertainties, about the types of inputs that you might be given, how you should handle those inputs. That's the next bullet point, the edge cases, is that, for example, if your function takes an integer as a parameter, what if it's negative? Ask them, what should I do in that case? Should I return -1 because it's like out of impossible input or, unsupported input? So return -1, return false. Just try and understand what exactly you should do in all these cases, and understand the problem, in depth, and make sure that you understand it before you start coding anything. And then if you think you have a solution and you want to propose it to them, kind of explain it on a high level before you start really coding it. Maybe you can write a little pseudocode or a few comments about like the stages of your solution. Say, I'll take the list as input and sort it first, say that. And then, look at, go backwards, in decreasing order. This is just an example. And so that they can kind of hear your solution and you've outlined it, and so that they know generally what you're going for. And if it's really off base, if it's really far off from what they're looking for, maybe they'll tell you that, so you don't waste your time completely. And so you just want them to know what you're going for before you start. Okay. So the second E, okay, is execute, right? Second E is execute. So now that you have a pro solution, you think it's good, your interviewers heard it, you need to start writing it, of course. But as you code, you really need to talk through your thought process. Explain whatever line you're writing or whatever block you're writing. Explain why you're doing it, what you think it's supposed to be doing. Because, this is still an interview, even though you're writing code. It is, this isn't just an online assessment. You're not supposed to just put your head down and write and write and write. Your interviewer wants to see how you approach the problem, and think through it creatively. And most likely you'll also encounter some obstacles, right? You might forget, you might have kind of forgotten the part you need to write, and you'll say, you might, pause for a second or get stuck. And so this will kind of help you, right? Because if you make a mistake or you get stuck, if the interviewer knows what you're thinking or what you're trying to do at that part of the code, they can give you hints, right? And they can kind of guide you toward the correct solution if you can't figure something out, if you're stuck. But if you don't explain your thought processes, if you're not talking at all or barely talking, they won't know what you're writing. They won't know what you're trying to do. And so they can't help you at all. And the interviewer often does help you a lot. Second bullet point, you want to keep your code readable, right? So this isn't just about solving the problem and solving it efficiently. Another big part of it is that even though this type of problem is probably not similar to, the software you're going to be writing for like an application on the job, they still want to see that you can write good software that's going to be maintained, even though that problem itself isn't, of course, can be maintained like a real application. You want to be able to write, they want to see that you can write code that's readable, right? Because someone is probably going to be reading your code. So for variable names, choose Boolean variable names, meaningful variable names that make sense, right? So unless it's like a for loop iterator, like index, don't just choose like a single letter. Other than that, also other than variable names, if you need to, right, if it's a long function at all, or even a medium length function, you should probably break it into multiple functions, like helper functions that can do some sort of subsection or subroutine of the process. And that would keep it kind of more modular, your code more modular. And also going back to what I was saying before about it being often an iterative question, the modularization into separate functions will also help with that. If you need to modify something, or you can change it piece by piece instead of having just all this one big block that's just harder to work with. So if you need to modify it to work when they give you like a new complication, a new difficult, a new type of input, or a new part of the problem, you can modify it much more easily. And then the third E, evaluate. So once you've written your solution, you think it's good, you think it would work. You need to walk through some sample inputs. So often, maybe they'll give you a sample input. Maybe you have to think of, you'll just have to think of types of inputs. Maybe they'll give you like one or two, and you can think of more. But sometimes you can actually run it in a test environment, but often you can't, and it's just kind of a text editor, but you won't run on anything. So sometimes you'll just need to walk through it yourself, like line by line, and kind of go through your code and show that it will process the input correctly and lead to the correct output. And of course, you want to make sure that your code is good, so you want to really test it. So try and think of, again, going back to the edge cases that I talked about before, think of those particular types of sample inputs that will break your code, because you want to show that it's robust and they can handle those inputs. So you don't want to, you want to give your code a hard time. And again, already mentioned this, but time and memory complexity, they often want to see that, and sometimes they'll usually ask you about that after you write your solution. So state that, answer them. And you can go line by line or sort of block by block and say, oh, the time complexity of this part is this, this part is O of n, this part is O of n squared. So overall, it's O of n squared because, sequentially. So, kind of break it down piece by piece and show them your thinking on how you arrived to your solution on or answer on the time complexity. So in terms of the strengths and weaknesses of your approach, you kind of can compare and contrast and talk about other solutions and how they compare. And this is, again, of course, related to the time and memory complexity. You can say, maybe your solution is very fast, right? Maybe it has a really good time complexity, but it uses a lot of memory. And so you can kind of state that and say, maybe if memory was more of a concern, we could go with a different solution that would be more efficient on memory, but be a little slower, perhaps. And again, another related bullet point, these are all kind of interconnected. If you would think of a better solution, maybe, but you didn't implement it because you thought it might be too complicated, or you just didn't think of it until sort of the end, you can kind of discuss that and say, oh, well, this other solution might also has a lot of advantages, so I would do that if I could do this again, or if I had more time. And often they'll ask you kind of, going back to the, the added complications or the iterative process, they might ask you like how you would handle, you don't have to write it necessarily, but they'll say, we don't have the time, but how would you handle if I added like this complication? And so again, that kind of relates to building a better, more, I guess, future-proofed example or solution. So, sure. All right, so we're going to pause for Deloitte and continue when they're done.
That's about it. Oh, sorry, my apologies. Did not know how to be not held that close. All right, so thank you all for your time. Happy to talk with you all today. We are members of Deloitte Consulting and wanted to talk with you guys a little bit about the role as well as some of the opportunities that Deloitte has. So first, let's start with the introductions. I'll go ahead and pass it over to Kelsey.
Yeah.
Well, I'm Kelsey Lecker. I graduated from UF in 2019 with a degree in industrial and systems engineering and started at Deloitte soon after that. So I've been at Deloitte for around 5 years now. We're based out of primarily the DC office. So a lot of us here this week and next will be from DC. Some recent experience, I've mostly in consulting, we'll get into it a little bit, but on multiple different projects. So some different ones I've been on have been around go-to-market strategy and in the federal health sector. And then just quickly, I think my favorite place in Gainesville, favorite restaurant is Boca Fiesta. We went there last night for dinner. It was great. And then favorite UF memory is just going out with friends and having friends and family all close by in Florida. So that's a little bit about me, and I'll turn it back over to Ryan.
Yeah, thanks, Kelsey. So yeah, like she was saying, we are mainly based out of the DC office, specifically over the bridge in Roslyn. And I started about a year ago, and I was in August 2023. So my current engagement is I am working with NAVFAC, which is all of the naval facilities, doing some data management for them, working on kind of optimizing several key things such as like personnel and construction, as well as different kind of initiatives that they have identified as top priority. And my favorite place to go in Gainesville is the Swamp. The atmosphere was unlike anything else. Best stadium in college football, in my opinion. Definitely not biased in that. And a favorite UF memory was definitely the 2022 game versus Utah. That was a great game, season opener, pick on the 1 yard line. Everyone went crazy. So best time. All right, so to talk a little bit about what Deloitte is. So Deloitte is definitely very big. So I'm sure that some of you guys might kind of think like tax and audit when you hear Deloitte, because that's kind of where it is in the business space. But more specifically, we are under the Deloitte Consulting umbrella. And so within consulting, they have commercial clients as well as GPS, which is the government and public services clients. And those are who we work for specifically. So to talk a little bit about what Deloitte Consulting does, I know that this can be a very broad term. Consulting is sometimes kind of like what even is really consulting, like what are they doing at the end of the day? But to shed a little bit of light on that, really what it kind of comes down to is working to solve problems. So a lot of different businesses have problems in very diverse spaces, which is why consulting kind of has that appeal of being able to like work on different fields, different projects. And one of the main things is really going in and like trying to identify like exactly what the current state is, and then taking a look at the future state. And the job of the consultant is to help bridge that gap, whether it is creating code and writing systems that are going to be optimized, or whether it's like AI implementation for different learning management systems, or very diverse kind of work that you can kind of undertake. You can, what I love about it is you can go as like technical and like coding focused as you want, or you can go a little bit more and lean in on the actual kind of functional and like strategy side of things. So that is what consulting is all about. And now to talk about the clients, which really is what kind of makes the work special at Deloitte GPS Consulting. So we have the opportunity to work with very, very large entities, and the amount of impact that like kind of 5 lines of code can have really extends when you're working with a project or with a client that, for instance, is handling $500 million. So you can really like help to optimize, and the kind of impact that you have, at least why I really enjoy it, is you're able to see some of those things kind of come into more real life. For example, like one of my friends was working on the IRS account, and she had implemented a new technology that made filing your taxes way easier. And I had to give her a big thumbs up and a pat on the back when I went to file my taxes last year, even though it still wasn't fun. Right, now to pack it back over to Kelsey to talk a little bit more about UFMP.
Yeah, just a quick show of hands with based on levels, wondering how many freshmen we have in Okay, sophomores, juniors, and seniors. Okay, great. So big variety. This slide is going to cover basically our program that we really want freshmen and sophomores to apply to. So our internship is mainly focused on juniors who are going into the summer before their senior year. So this is an opportunity to apply to UFMP. It's a kind of 8-month professional development program where we would pair you up with a Deloitte employee who also recently graduated from UF, probably somewhere neighbor to you all. And you would really get to have monthly check-ins with them and talk through professional development, career goals, resume review, and in consulting, we have a unique interview that, if you guys are familiar with, it's called a case interview. So we give you a business problem and you talk through how you would problem solve in relation to people, process, technology, things like that. So I think you all are very intelligent and top talent. So I think you all would do great in that. I know that you all have analytical minds. So that's kind of a little bit of information on the case interview. But just to go back to UFMP, really encourage anyone who is a freshman or sophomore that's interested in Deloitte and wants to learn more to apply. The QR code here should take you to that application. Just to wrap it up on the positions that we're here hiring for this week and next week, we'll be on campus. We have a few positions listed on GatorLink. So we have a solutions engineering analyst and a business technology solutions analyst. Those are both the positions that I would recommend this group applying for. We are looking for students graduating between December 2024 and 2025 for full-time, and then for the summer scholar, which is our internship position, students graduating between December 2025 and August 2026. So applications for those positions are due by end of next Wednesday, so a week from today. If you guys have any questions, we're happy to answer anything on those specific positions, but we will also be at the technical career fair on Monday. A few of our additional colleagues will be there. So definitely recommend you going there to talk to some of them. I think some of them are a little bit more technical than I am. So could definitely answer any questions you guys have on specific experiences at Deloitte and in consulting. I think those are the main things to highlight. Just one other note that I wanted to caveat is due to the nature of our work in the government, we do require clearances for a lot of the work. So right now we are not sponsoring students for GPS students with visa or anything like that.
Yo, what's up?
Yeah, I think that's all.
Yeah.
QR truly sign up for some of our events, but happy to answer any questions.
Actually, yeah. Tell me.
Career showcase on Monday. Yeah.
Given the recent events with UI.
But
Specific right now, but I'm
not aware of what happened with EOI.
I'd be happy to talk with you.
I think I can make out.
I'm not just like familiar with the UI, the employee who died. Oh, well. Due to company culture, she was overworked. Gotcha. Well, I know that definitely can be an issue in some kind of consulting fields. However, Deloitte GPS specifically, we really take very serious kind of concern about like mental health as well as work-life balance. So you, especially working with government clients, it's honestly kind of hard to get them on the phone even on a Friday sometimes. You know, like my client likes to push his daughter on the swing on Fridays. So I know it's strictly off limits after 2 p.m. with him. So with the kind of nature of the government kind of working a little bit slower than some of the commercial, they're not really like burning the candle at both ends. So that's not something that really comes into play too much with Deloitte Consulting, specifically GPS especially. But yeah, no, that's definitely a tragedy, and that is not something we promote at Deloitte whatsoever.
Can you talk a little more about like what the case interview is? Is it more focused on like the consulting, like business side, or like?
I can look at, typically it's, so if you're applying to the like solutions engineering role, that's a more technical role. So the case will be more technical in nature, not I know you guys were giving a presentation on like coding interviews and things like that, nothing like that, but it'll just have a more technical nature, maybe on a technical topic. And sometimes there's some quantitative analysis required that you would just do on the spot with the interviewer. And it's very question based. So they would give you a problem and then I would recommend asking them to repeat it again. I think some of the advice that you guys were giving earlier was really helpful. And where there's room for you to ask follow-up questions, they usually have some more information to give you if you ask the right questions that can help you kind of answer the question. And then it's really just thinking through the problem and how you would best solve it. They're really just looking to see how you think and talk out loud to them and make sure you're an effective communicator. So for our interview process, great question. It's a 30-minute behavioral interview and a 30-minute case interview. And then if you are selected to come to round 2, it's another 30-minute behavioral interview. And those interviews will be the first week of October, or second week of October. So application deadline next Wednesday, and then you'll hear about an interview the following week.
And just to follow up on the case, just to give you like kind of a speed run of like what a case would be. So let's say a case would be a question such as like, so the TSA wants to reduce the time to go through the whole process from like an hour to 45 minutes. Basically, they would go through, ask you that, and you would take about like a minute or two to kind of gather your thoughts after you ask any like clarifying questions. And then once you've clarified like some of your thoughts and gotten a little bit more, it's important to kind of structure it like Kelsey was saying. You would do like people, process, and technology. So for the instance that I gave, first we're going to take a look at the people. So first we would want to talk through all of the different people to understand and make sure that they're trained properly. Additionally, we would take a look at all of our staffing and make sure that we're optimizing and having the right number of staff employed at current times, especially when the people are going to be coming to the airport more frequently. To look a little bit more at the process, we would go ahead and start taking a look at all the different bottlenecks and analyze the amount of time that people spend in each step of those, and then try and figure out from those bottlenecks, which of those are we able to do parallel, as well as which of those are we able to either reduce or combine into kind of a single step. And lastly, to look at the technology, we would go ahead and analyze all of the different machines that are used, such as the different scanning or technologies that are used for background checks, and try and see if there's any ways that we could make these a little bit more efficient or combine kind of the steps to vet people to kind of push them through the process. So that's kind of just like the thinking through it.
Yeah, that's a really detailed.
Yeah, and just to add, if you Google like Deloitte GPS case interview, there's some examples on our website that you can look at, and we'll definitely recommend practicing a few of those with friends to talk through it before you get to the actual interview.
Either one of you guys, but how do you employ like what you studied in school at your job, your daily?
For me, I think as I mentioned, I studied industrial and systems engineering, so I think part of it, I guess tactically, like a lot of the supply chain that I learned in school, I can use moving forward, process improvement, things like that. But I would say at the end of the day, the main thing is like the problem solving mindset that I learned throughout coursework and like effective communication. We do a ton of client presentations and things like that, and I think a real big key is having that effective communication.
Yeah, no, I agree. It's definitely a lot of it is more so, like she was saying, like that kind of problem solving approach. I'm sure that they teach you like kind of also like kind of that coder's mentality, like kind of like how are we going to break this down? How are we going to approach it? That's like a really big part of consulting is like really being able to take like that future vision and like break down and kind of write that roadmap. Like how are we going to get there? So that's, yeah, pretty much the mindset.
You guys mentioned that for the mentorship program, there's like a mentor that goes with you through your 8 months. But for the internship, like the summer scholar program, how does that work with mentorship, and how do you guys like measure success for the interns coming out of that?
Yeah, I can speak to that. I was actually went through the internship process about 2 years ago. So first off, you go like get paired up with a project. So they put you on actually like a real project with like full leadership. And one of the really cool things that they have is like they have all these like different check-ins. So you get to speak with a coach that's actually not on your project, but then also check-ins with your senior managers. So one of the really big things that we kind of emphasize is like clear and open communication. So kind of emphasizing to them, like, what are you looking to get out of it? And then also like trying to work with your senior manager to kind of see how you can fit into that project and kind of both grow in that role, as well as like also make sure that you're kind of getting like tangible values to them. And it really is just more so kind of what you make it. And a lot of the things that make it kind of successful internship is that you learned a ton and you got to kind of work with all the senior leadership and kind of see what it's like to actually be in the real like kind of Deloitte consulting role.
Thank you.
Yep. All right. Well, appreciate all you guys' time. It was great speaking with you all. Apologize about the light earlier. That's a very tricky one. Yep, thank you.
All right, so that was really good with the Deloitte people, but we're going to continue on with our presentation. Sorry, it's a little weird that we did part of it and then continue with the rest of it, but we're going to be continuing now. So first, I'm just going to be talking very briefly, again, just not getting too deep in depth into the technical part of it, because that's something you kind of have to practice on your own. But I'm just going to be talking very briefly about like very basic data structures. If you already, I mean, a lot of you already know this, probably most of you, but it's just an overview, so just bear with us. And we're just going to be kind of comparing and contrasting them, and even though they're very simple, use them as kind of an analog for, in general, how you should structure your thoughts, right, and how you should think about things. So, of course, arrays are just a linear ordered sequence of data, right? I'm sure a lot of you already know that. Some of you don't. That's fine. But what I want you to think about is think about like a time complexities, right? Because when you're thinking of a data structure, whether it's very simple, something like an array, or something more complicated like a priority queue or like a tree, you need to think about the time complexities of their operations. That's kind of the primary thing. You know, what can they do? What can they not do? And for the things that they can do, how long does it take them to do it? So, for example, for an array, just to, as a simple example, right? The advantage of it is that it has a constant time like lookup or access for a specific index. If you want to access it at a specific index, like we are here in the picture at index 3, that's constant time or O1. So it doesn't change with how long the list is. And a second advantage of it is that because it's an ordered sequence of data, you can sort it, and it's often easy to sort because it has like in a lot of languages, some built-in function to sort it for you. So again, thinking about the operations that you have on a data structure, even though it's something simple like an array or a list, is what you want to be thinking about when you're selecting a data structure. Whereas you can compare and contrast that with other options for data structures, other ways to organize your data, like, for example, a map or a hash map. So in Python, they're called a dict. And of course, they pair a key to a value, right? They kind of create an associative mapping. And the keys are unique and values can be repeated. For example, here we're counting actually, there's 2 recurrences of Apple from the list previously. These example images are related in that way. But again, thinking about the operations and the time complexities of those operations, for a map, it's all about accessing, right, a key that's associated with a value, or a value that's associated with a key. So you can give it a key and get the value associated with it in, again, constant time, all one time. So that's its strength. That's its, its power over an array. Whereas, if you wanted to implement this with a list of lists or an array of arrays, to call it something different, where each inner array is length 2. If you wanted to find a particular value associated with a key, you would have to iterate over every array, right? So if you're given a problem and there's any part of it where, whether it's the overall problem or just a subsection of it, where you want to be, associating some value with some other value, you should be thinking of a map. And maybe some of you that will seem very obvious, but again, this is just a general like thought process. You need to be thinking about what's your use case, what are you trying to do, and what data structures or algorithms support those types of operations or like processes. And one more, sets, for example, are unordered. There's no repeats. All the elements are unique. And what their strength is checking for membership, right? If you just want to see if something's in the set, like we are here, the banana Is it in the food set? Yes, it is. Or what and on, it's not, right? That's again, over one time, very fast. Whereas, again, if we were talking about a list, you'd have to iterate over them all. So it's O of n time, where n is the length of the list, the number of elements. And just to be technical, sets are similar in their underlying implementation to the maps, like we were talking about before, but there's no values associated with the keys. It's just basically the keys. So again, thinking about the use case, if you're given a problem and any part of it is about, you're going to need to check for membership very quickly, you should be thinking about sets because that will be more efficient. It'll be faster than if you were to store them all in a list, for example, and iterate through them all every time you need to check if an element is in that list. So you can extrapolate that outward, that thought process outward. That's a simple example, but extrapolate that outward into more complicated examples with more complicated advanced data structures. But we will talk also, again, just a brief overview. We can't go through them all. And even this isn't an exhaustive list. There's some that are left off the slides, but just kind of to give you ideas of what to study, what you should be looking into. Here's a few examples of kind of types of problems or topics of problems. So one of them is, interval type problems. And by the way, all these examples, there's one example for each of these problems, as well as on the next slide. Those are all LeetCode problems, like the titles of LeetCode problems. So if you want to maybe take a picture of that or just write it down, so you can try those out. I think those are good example problems. So for interval problems in particular, it's all about what it sounds like, intervals, right? So you could think of it as maybe an interval in time or space, but these intervals have like a start and end point. And so you can represent those as integers. So for example, A has this start point at 0 and end point at 5. And the problems are usually about how they overlap and how they kind of interact with each other. So you can see the fact here that A is entirely overlapping B and so forth. And for example, A is not overlapping H down here at all. And so that's usually, that's a big, that's what the problem hinges on typically. Figuring out if, intervals overlap or maybe just trying to select as many intervals that don't overlap as possible. But this type of problem, there's kind of, when I say topics of problems, it's kind of multiple things. So for intervals, it's usually very obvious when they give you a problem that it's an interval type problem, but that doesn't necessarily tell you how to solve it. Whereas some of the ones we get to down here, like priority queue, that's not really obvious. Like when they give it to you, you don't really know, like it's a priority queue type problem. It's just kind of a data structure that you use internally to solve the problem. So number 2, linked lists. You're probably familiar with that if you're taking programming 2 or advanced, 3503 or 3504. So unlike arrays, you have non-contiguous memory where the nodes point to the next element of a list. And again, similar to intervals, this type of problem is something that's very obvious when they give it to you. Like they'll tell you it's a linked list and you have to do something with it. For example, maybe reversing it or removing a certain node. This problem is pretty interesting. It's kind of swapping the nodes in pairs. So for example, for this list, it should return B, A, D, C. So that's, I think, an interesting problem. You can give that a shot if you want a little homework. Number 3, priority queue. So again, this is a kind of different type of topic. I'm kind of using the word topic in multiple meanings, where this is just a data structure that's used within the problem. It's not obvious when they give you the problem statement that you need to use it. And that's a big part of problem solving as well, is looking at the problem statement and kind of figuring out what can be used to tackle that problem. So it's a priority queue is some data structure that gives you very easy constant time access to the minimum or maximum element, not both at once. You select it when you create the data structure, when you initialize the priority queue, which is actually, it's not sorted though. That's a big misconception. When I first learned about priority queues, it was very confusing to learn that they always give you the minimum and you can insert new elements, but they don't keep it sorted internally overall. And so sometimes it gives you some advantages over just having a fully sorted list. And here's an example problem: the kth largest element in an array, where k is some integer. And some more even advanced topics. This is all a matter of opinion. So if you think maybe you think some topics from intermediate topics are actually harder, but so greedy. This is actually a wide range in difficulty. I said down here. So sometimes greedy is a very, very simple problem, but sometimes it's actually a very difficult problem. Basically, what it means is it's just typically some optimization problem, like you're trying to maximize or minimize some value. And a greedy approach means you take some locally optimal choice, which means you're trying to kind of a short-sighted approach, where you're just kind of looking at like taking the best option at each step. And in some cases, in some problems, that will lead to a global maximum, like the overall optimum, could be minimum as well. Global optimum, I should say. But the problem with it is sometimes it won't lead to the global, the overall solution, the overall optimum, like optimally for the whole problem. So it's kind of difficult to know when it will work and when it won't. And that's just kind of practice, like to recognize that. And so, yeah, it's pretty difficult to prove it will lead to optimum. And sometimes it's difficult to know exactly what to select, because it's not just always like the largest or smallest. There might be multiple factors, like when you're talking about intervals, these topics can either be combined. So there's some interval problems that might be, a greedy interval problem. But sometimes it might be difficult to select, do I take the longest interval, the shortest interval, the interval that ends the latest or starts the latest? It's not always super clear. So this is a good example problem. Trees and graphs. I'm going to kind of speed through the next ones because we don't have a lot of time. We might go a little bit over time. Sorry about that. Trees and graphs, it's kind of just a network. A graph is a network like this. A tree means there's no cycles. And so some algorithms that you can do on a breadth first search with a key, which is a type of data structure. Depth first search is an algorithm that uses a stack, which is another type of data structure. Good example problem. And dynamic programming, which is a pretty difficult topic as well. But it's kind of difficult to wrap your head around at first, I think, in my opinion. But once you get it, it's kind of a repetitive pattern, and you just need to recognize it. But the implementation is often very similar. And you kind of use recursion, or technically you don't always have to use recursion, but you use which is a problem in terms of itself, kind of, where similar to how Fibonacci, the nth Fibonacci number is the n-1 Fibonacci number plus the n-2 Fibonacci number, similar to this tree. But you kind of remember the results, right? So for example, Fib2, instead of recomputing it down here, there's no need to recompute it. You can store it and then reuse it. So that's kind of the basic idea, recursion, and then remember the results. But you can also do it iteratively sometimes as well. And I know this is a very brief, we're kind of rushing through it, but this is just supposed to give you an overview, kind of a general idea of what to study, what to practice. We do have more slides to get through. So yeah, speaking of practicing, how do you practice? How do you prepare, right? Because this is just giving you kind of some tips, some general best practices. But, in terms of actually writing the code, that's something you just have to put the time in and practice it on your own. So of course, in general, the core of it is going to be doing it on these websites like LeetCode, maybe HackerRank. I think some good lists, people compile good lists of problems that are very representative of and interesting and representative of like real interview problems that kind of get to the core of like what these problems are. So for example, Glide 75 or NeetCode 150, I think those are pretty good lists that have from a wide range of topics. Like the ones I mentioned before, all those topics, or maybe some topics I didn't mention, like sliding window, if you know what that is. I would say a really good point is if you can't solve a problem yourself within maybe, depending on how much time you have, within maybe like 20 or 30 minutes, or if you want to use some other length of time, that's up to you. I would say it's good to look at the solution and understand it, right? Because if you don't really gain anything, if you just look at a problem, try and think about it, and you can't solve it, and then you just move on, you haven't really learned anything because, you didn't learn anything. So it's good to look at the solution. If you can't solve it for a while, try and solve it on your own. But if you can't for a while, look at the solution and really try and understand it, and maybe come back to it like soon after, but not too soon, and then see if you actually retain that knowledge and if you've really learned something. Really take the time to think about your answers. Be careful. Or take care when you're writing code, and kind of practice as well, right? Because you're going to have to talk to the interviewer, like I was saying before. You need to explain your thought process as you go. So do that as well when you're writing code. Kind of maybe just talk kind of in your head about like what you would be saying to an interviewer if this was a real interview problem. I think it could be very useful to do mock interviews with maybe friends. I know some clubs do it, or maybe you're not friends with them, but it's just some other connection in your network. Some companies do it as well, some mock interviews. And prepare questions. So at the end of the technical interview, as well as the behavioral interview, you should ask questions. So this applies to both types of interviews, but especially in the technical interview, you can kind of ask more technically geared questions. So maybe about the tech stack, because you'll be talking probably to a software engineer or someone in an engineering role. So you can ask questions about like the technology, about maybe the technologies they use, the languages they use, and how that's organized and how the teams are structured. And just kind of a last bullet point as a last caveat, remember that you need to get the interview before you can actually do the technical interview. So I don't think this is a really common problem, But some people, I think, probably kind of overemphasize, at least in when they're talking about it. Maybe they don't do this personally, but they kind of overemphasize leak code. So remember that for all these technical skills, maybe we're really good at these technical types of problems, but you, of course, you need to have a decent resume or a good resume, ideally, to get the interview in the first place, to pass the resume screening and get the interview, right? So if you just do leak code, and I don't think many people are doing this, of course, but it's possible. And just a warning: don't just do leak code and spend all your time on that. Or maybe you do have a decent resume, but it's still possible to kind of overemphasize or over allocate time to the technical interview. So trying to be very balanced is basically my point. Have a good balance, like a healthy mixture of a good resume and like extracurriculars and other things, research, maybe be a teaching assistant and so forth, and balance that with the technical interview part. Okay, so that's it for the technical specific stuff. Just general tips that apply to both types of interviews, and I think Saurabh will do that.
Yeah, so what we covered today is more meant to be a framework of how you want to prepare for these, how you want to look into studying for the behavioral and technical interviews, rather than like a comprehensive list, because obviously you're not going to be able to cover everything in 1 hour. But yeah, if you haven't heard about Blind 75 and LeetCode 150, like we mentioned here, I would definitely take a note of that on your phone. Look those up later. Those are meant to be beginner approaches to like solving all the major LeetCode problems that are asked at big companies and everything. The other general tips: so before the interviews, you want to be able to research the company, so understand the company's mission and culture, learn about the recent news and achievements, and show enthusiasm and passion about the company and the role, because that's what they're looking for. They're looking for passion in the role itself. During the interview, you want to stay calm and collected. Again, you want to be able to ask for a minute to think about your answers, because at the end of the day, the recruiters are more looking for how you're able to explain the thought processes out loud, rather than like how quickly you're able to come to an answer. So they're always able to give you 1 minute to think about your answer. If you're stuck, don't be afraid to ask for help. If you're stuck, because they're not looking for like if you're able to solve every single aspect of the problem, if you're able to communicate a problem that you're stuck on, the recruiter might be able to help you out, and then you'll be able to demonstrate more later on in the problem, right? And be honest if you don't know something. If you don't know something, explain how you would approach learning the problem, how you would approach like asking someone else on the team maybe, or searching this up online. But don't lie and don't make up a solution. That is not going to work. After the interview's over, you want to make sure to follow up with the interviewer, right? So send a thank you email within 24 to 48 hours afterwards. Just be like, hey, thank you for this. I really enjoyed talking with you. Maybe bring up something specific from the interview. Get yourself in their head and make sure they remember you. And always leave like a good impression in terms of how professional you are and how much passion you showed to the interview. Even after you get rejected, keep in mind that this is a numbers game at the end of the day. They're interviewing a ton of candidates. They have tens of thousands of applications to go through at times. So just stay professional even after rejection. But yeah. Speaking of building your resumes to get into the interviews in the first place, our developer team applications are open. These are open for beginners and advanced people as well. So no matter where you are in terms of computer science, I would definitely highly recommend applying to this. I think applications close in 2 weeks, September 30th, but we are starting interviews as soon as we get the applications turned in. So definitely apply to that. We're going to be posting this later as well on the Discord. So just keeping that in mind. If you haven't signed in already, here's a sign-in form. And career fairs next week. It's very important to prepare for if you're a freshman or if you're a sophomore, junior, upperclassman as well. Highly recommend going to that, no matter where you are in that. It's huge for your career. You're going to get a lot of internships, a lot of experience out of that. But the Wednesday following that, we have a game night social. That's going to be Wednesday, 6:30 p.m. in our normal room in Lit 109. But yeah, that's all we have for today, I believe. We should be posting all the slides and the rates information as well after the meeting's done on the Discord. But thank you for your time. Thank you for coming.